In the workspace I have added an AC power supply. The amplitude is set to 1 volt and the frequency to 1 Hz. When we look at the output on the waveform viewer, we can see the sine wave signal. Notice how the signal alternates from 1 volt to -1 volt continually. Let's pause the simulator to examine the sine wave. The frequency of the AC signal is 1 Hz, meaning it will complete 1 full cycle every second. 1 cycle is when the signal goes from 0 volts to its peak positive voltage, then back down through 0 volts, then reaches its peak negative voltage, and then back to 0 volts. The time taken to complete the full sine wave is called the period. The period is represented in seconds. To calculate the frequency, we divide the period by 1. In this example, the period takes 1 second. So frequency equals 1 divided by 1, which equals 1 Hz. If the period was 1 millisecond, the formula for the frequency would be frequency equals 1 divided by 0.1, which equals 10 Hz or 10 cycles per second. There are 3 other calculations we use when measuring the waveform. These are peak voltage, peak to peak voltage, and RMS, root mean square voltage. The peak voltage is when the sine wave reaches its maximum positive voltage. In this example, we can see the peak voltage of the sine wave is 1 volt. The peak to peak voltage is the maximum positive and negative voltage. Our sample sine wave has a peak to peak voltage of 2 volts. Root mean square voltage is the most common mathematical method of defining the effective voltage or current of an AC wave. The RMS voltage is calculated by multiplying the peak voltage by 0.7071. So for our example, the RMS is 1 volt multiplied by 0.7071. So RMS equals 0.7071 volts. Let's look at another example. In the UK, the household power supply is 240 volts RMS. To find the peak-to-peak voltage of this, we multiply the RMS value by the square root of 2. So to find the peak-to-peak value, we multiply 240 by the square root of 2. The square root of 2 is 1.414. So 240 multiplied by 1.414 equals 339.36 volts peak to peak. Divide the peak to peak voltage by 2 to find the peak voltage. 339.36 divided by 2 equals 169.68 voltage peak. In Europe, the supply voltage is 110 volts RMS. 110 multiplied by 1.414 equals 155.54 volts peak to peak. 155.54 divided by 2 equals 77.77 peak voltage. Please note that household power supplies are very high voltage and should not be used in experiments under any circumstances.